What's up guys, it's Iman Fiaz and today's video is on reactions of ions in aqueous solutions. I was going to go through the whole transition metals question paper. I had a look at how many pages that was, 32 pages. I definitely can't do that on a school day because if I do that I'm just going to not revise anything else, because that'd probably take me maybe 3-4 hours, I don't know. But anyway, and those included, that transition metals question paper included other topics like titrations, mean titer, something not really relevant to transition metals. This is what I really want to go through as well. Anyway, the reactions of ions in aqueous solutions. Question 1a, discuss the role of iron as a heterogeneous catalyst in a Haber process. Include the meaning of the term heterogeneous, how it acts as it, and the factors affecting it. Okay. So every time you get this, you need to split it into 3 stages. Hopefully you guys know about that by now. If you don't, please practice these 6 markers. So stage 1, can you guys hear me? Yes, you can. Stage 1, heterogeneous means catalyst is in a different phase/state from the reactants. What the catalyst does is a catalyst speeds up. Sorry guys, I need to do that, move that over here. Speeds up a reaction and is left chemically unchanged. Okay, stage 2. How iron acts as a heterogeneous catalyst. Well, hydrogen and nitrogen absorb onto the active side of the iron. The bonds weaken / reaction takes place, and then the products desorb / leave from the surface of the iron. Stage 3. What was stage 3? The factors affecting catalysts. Well, a large surface area of iron by using powder. Catalyst is also poison. Catalyst is poisoned when sulfur binds to the catalyst, hence active sites are blocked. Fe2+ions, give 2 equations and then write down why reaction is slow. So why the reaction is slow, how many marks is it? It's 4 marks. So 2 marks for the equations, 2 marks for the explanation. So reaction is slow because there's 2 negative ions. 2 negative ions, which obviously repel each other. Therefore, high activation energy, high EA. 2 negative ions repel, therefore high activation energy. That's the hard part. The easy part is copy and pasting the 4 equations, because it is easy. It's just have you memorized it or not. So 2Fe2 plus S2O8 minus 2SO4 minus plus 2Fe3 plus. And guys, over these next couple of days I'm going to be posting so many videos on these equations from transition metals. So many. They're going to all be YouTube shorts as well, because I really want to go into that kind of thing, uploading YouTube shorts to grow my channel. And also it makes sense, like maybe one equation I go through one YouTube short, one equation. So 2Fe2 plus S2O8 minus, or 2SO42 minus plus 2Fe3 plus 2Fe3 plus 2I minus or 2Fe2 plus I2. A reason Z and 2 plus ions do not catalyze a reaction is that Zn ions only have one oxidation state. only have one oxidation state of +2, therefore only Zn2 plus. Question D, iron reacts with dilute. Sorry guys. Iron reacts with dilute hydrochloric acid to form iron 2 chloride and hydrogen. A 0.998 gram sample of pure iron is added to this mixture of hydrochloric acid. One of these reagents is in excess, other reagent limits the amount of hydrogen produced in reaction. Calculate maximum volume meters cubed of hydrogen gas produced at 30 degrees Celsius and 100 kilopascals. Give your answers through significant figures. Identify the limiting reagent equation, reaction, and gas constant, or is that? So, how many marks is this? 6 marks. Okay. So, first things first, just use the information I'm given. Alright, so moles of iron, moles of Fe, because I need to identify the limiting region, is 0.998 over the mol of iron. I'll get my periodic table out from my school bag. And I also taken out my transition metals booklet, because all those equations, guys, trust me, a lot of videos can be posted soon. And I'm actually kind of excited for all these equations. I know it might seem crazy, but because it gives me a lot of content to work with. And it's relatively simple as well. So the mol of iron is 55.8. Then I'm going to work out the moles. I'm not going to put that on my calculator just yet. Work out the moles of HCl. HCl, which is 30 divided by 1000 times by 1. So therefore it's just 30 divided by 1000, which is 0. I'm going to show the times by 1, but yeah, you don't need to. I don't think so. So 30 divided by 1000 times by 1, or 30 divided by 1000, don't make any, is 0.03. And then what is this? The moles of iron, 0.998 over 55.8. 0.01789. Okay. Then I know it's a 1 to 2 mole ratio. I've got the moles of iron and need to see which one's the limiting region. Well, if I do the moles of iron times by 2, I get 0.0355. So the one in excess, so Fe is in excess, and therefore HCl is the limiting region. You will always, I'm pretty sure, be asked about equation on this. Ask the question about this. Which one's in excess, which one's the limiting region. So you might as well just prepare for it beforehand and learn these key facts. So yeah, HCl is the limiting region. Fe is in excess. Okay. Now I want to calculate maximum volume of hydrogen gas produced at 30 degrees Celsius, 100 kilopascals. So now I'm going to use something called, well, you guys definitely should know this by now, PV equals nRT, ideal gas equation. So I want to work out the volume. So V equals nRT over P. Now R is fine, temperature is fine, pressure is fine, it's the number of moles. Well, I've worked out the number of moles of HCl, so to work out the number of moles of H2, I'm just going to do the number of moles of the limiting region. So it's very important to identify this. I use the moles of the limiting region, not the moles in excess. So I'm going to put that down, write that down somewhere. Use moles of limiting region, not the moles in excess, when given both. Please learn that, because if you then decide to use the moles of iron, you're going to lose all those marks, all those next 3 marks. So V equals nRT over P. Well, therefore, if I'm using the moles of HCl, then divided by 2, so 0.0150, and then it's just substitute that into there. Convert the centimeters cubed of HCl. No, sorry, that's what I'm trying to find volume. R is 8.31, temperature 30 plus 273, 100 kilopascals. You get, and the volume is always measured in meters cubed, so you get 3.78 times by 10 to the power minus 4 meters cubed. 3.78 times by 10 to the power minus 4 meters cubed. Identify A and state its color. So, precipitate A is when FeH2O. So now I'm going to pull up the booklet my teacher gave us with all these tests and everything and all the equations. And the funniest thing is that's not even all of them. Like, I think there's another extra, at least 5 more to learn as well. So with FeH2O62 plus with carbonate ions, I form FeCO3, and the color is green. It just says color, doesn't ask for the precipitate, it just says green. Give the formula B and state its color. Well, B is when this same thing, but instead of 2 plus, it's 3 plus, reacts with carbonate ions. An ionic equation for this. So the ionic equation, give the formula B. The formula of B. It's going to be 2 Fe H2O 3 OH 3. Oh, but it says the formula, so I'm not going to include number of moles. FeH2O 3 bracket OH3. Color brown. And then the ionic equation is 2 FeH2O 6 3 plus 3 CO 3 2 minus arrow 2 bracket Fe H2O 3 bracket OH 3 plus 3 H2O plus 3 CO2. Yep, perfect. Exactly copy and pasted from the booklet. Okay, and then it says explain when aqueous solution containing this ions has a lower pH than aqueous solution containing this ions. Well, the only thing that's changed is the charge. So 100%, I'm going to talk about the charge. That's 100%, that's what I'm going to talk about. But what else? So if I talk about the charge, starting it off, because it is 3 marks, so I can't just talk about that. I'm going to say Fe3 plus has a greater charge than Fe2 plus, hence Fe3 plus is smaller than Fe2 plus. Therefore, Fe3 plus ions are more polarizing, so more OH bonds break. And that's it. Greater charge, more polarizing, more OH bonds break. That's what you need to say. Question 2, another question like this. Give the formula of the white precipitate B. Well, the white precipitate B is here, and this is when aluminium Al2H6 3 plus is reacts with carbonate ions. So I will form the formula of B is therefore 2 Al H2O 3 OH3. And please, guys, don't make that silly mistake I just made, including the moles. I did that by purpose right now. Obviously, I made a mistake before here, but this time I did it by purpose. Don't include that. Don't include the square brackets. It's asking for the formula. It says ignore square brackets in the mark scheme. So say AL bracket H2O3 bracket OH3. Observation when it's added to the solution containing when it's added to the solution containing this. Well, this observation, white precipitate, yes, gentle bubbles. So yeah, bubbles slash effervescence, bubbles. And a given equation for this reaction. Wait, what? Oh, right, okay. It wants me the equation. So Al H2O 6 3 plus CO3 2 minus. But because it's this, obviously, and I've memorized the equation, which you kind of have to do because I don't know how else you're gonna get the answer. You get that, you get that, plus 3H2O plus 3CO2. 2AlH2O6, 3 plus 3CO2 minus our 2AlH2O3 OH3 plus CH4 plus 3CO2. Then it says, give the formula of the complex ion C. Well, C is when this reacts with hydroxide ions. So if I go to that, AlH2O6 3 plus with hydroxide ions, and it says white precipitate reacts to form a colorless solution containing complex ion C. Because it's a colorless solution, so formula of the complex ion C is Al bracket H2O H2O 2 OH4. But in this case, I am going to include square brackets because it says formula of the complex ion. So I need a negative charge, therefore the square brackets. The condition for the formation of C, we need excess. It needs to be an excess. But excess what? Excess, not hydroxide ions. Well, it is excess of hydroxide ions, but it comes from excess sodium hydroxide. It says that there. And then the equation to form the colorless complex ion C, so with excess, well then Al H2O6 3 plus H no. No, I am right. Yes. Wait. So I've got this. So it wants me to couple the equations together then. So this plus 4OH minus, and then I'll form my complex ion, AlH2O 2 bracket OH 4 minus plus, well then 4H2O. So yeah, be careful. This one is a bit trickier. You just have to add them together. So there's two steps, but it wants it in one equation. So you just add them together. Deduce the formula of complex ion A. A, complex ion A. Well, when AlH2O6 3 plus reacts with Na4EDTA aqueous. EDTA aqueous? Okay. This one is definitely a bit tricky. Definitely. Is Na4EDTA a ligand? Is it a big ligand? Okay, yeah, perfect. So, some cases in the exam, they'll give you, and this is only sometimes because you look at these, all of these are equations you have to memorize, but only here, it's a bit weird. You have to apply it, right? Well, EDTA, you should know is a ligand, but you kind of have to know that for transition metals, is a ligand, and it's also a big ligand. So when AlH2O6 3 plus reacts with a big ligand, so Cr minus, when it reacts with that, let me show you guys what happens. Let me show you guys what happens. Plus 4Cl minus, arrow, AlCl4 minus, plus 6H12. So what happens is a ligand substitution. So therefore the exact same thing is going to happen with this. But in this case, it's just going to be, well, it's just going to be the ion. So EDTA4 minus. So therefore, it's going to be Al bracket. No, it's going to be Al EDTA minus. That's all it's going to be. Yeah. EDTA minus. And then it says, explain with the use of equation why a solution containing this has a pH less than 7. So, a solution containing this has a pH less than 7. Well, I'm just going to add water to it. So, if I add water to that, so Al bracket H2O 6 3 plus H2O. Actually, I don't need to use that one. I can just use this. And then it's got Al H2O3 OH3 plus 3H plus. Yeah, the one from booklet. And then why it has a pH less than 7? Well, so now it's a bit of application, isn't it? But is it really? It's just the same thing about the charge of the ion. Anytime that this charge an ion, Al3 plus has a small size and high charge, and this weakens the OH bond, and releasing H plus ions. Question 3. Give the formula of precipitate J and state its color. Precipitate J. Well, precipitate J is when FeH2O 6 3+ is right here. It reacts with carbonate ions. So if it reacts with carbonate ions, the equation or the formula of precipitate J, formula is FeCO3, and the equation, let me give the equation first. FeH2O 6 2+ plus CO3 2 minus arrow FeCO3 plus 6H2O. Now, the more I do these questions, I actually really enjoy this topic because these are obviously all past paper questions and they look very simple. They just want you to recall the equations and the color green. Recall the equations, recall the observation. There are a couple that are a bit of application, but most of them are just like this. So yeah, question 3, formula precipitate J. Okay, I've misread the equation. That's 3+. Okay, so this is all wrong then. And so is that as well. The color's wrong as well. I've misread the charge on the ion, so don't do that. The formula therefore is FeH2O 3 H3. Color is therefore brown. The equation is 2FeH2O 6 3+ plus 3CO3 2 minus arrow 2 bracket FeOH3 H2O 3 plus 3CO2 plus 3H2O. Okay, give the formula of L and a reaction equation for reaction 2. So an equation for L, formula of L, sorry. Well, L is here. It's a complex ion, and it's once this reacts with Cl minus ions. So when this reacts with Cl minus ions, well, what is Cl minus ions? Ligand. So what's gonna undergo ligand substitution? So FeH2O plus excess Cl minus, and what is it? It's 3+. So therefore, the formula of L is FeCl4 minus, and then the equation is FeH2O 6 3+ plus 4Cl minus FeCl4 minus plus 6H2O. FeCl4 minus FeH2O 6 3+ plus 4Cl minus FeCl4 minus 6H2O suggests a reagent for reaction 3. Reaction 3, when I'm going from this with a 3+ to this to 2+. What is it? Zinc. Give the formula precipitate M. Well, precipitate M is when this H2+, reacts with NH3. So the formula of M. See, a lot of the times they don't even want the actual equations; they just want the formulas, and it's actually probably because it's probably more difficult to just give the formula because you're like, okay, do I write down the equation or not? And it's like, no, you don't. I just want the formula. But you still should write down the equation in order to get the formula, obviously. And the thingy is with M 2+ with, green is a color you're looking for. 6 marker. Oh my days, this is a real question, guys. Look at this. 14 marks. And if I go back to this, that is literally memorization. That's memorization. That's memorization. That's memorization. That's memorization. This, it probably obviously is memorization, but I need to go see what that is about. That's memorization. That's memorization. And this whole 6 marker is memorization. That's crazy. And that's 14 marks. Okay. Describe different shapes of complex and show how they lead different. Now, some use examples of complex cobalt 2 and platinum 2. Now, this one, I'm going to skip this one. I'm going to skip this one because it's not with the theme of all these questions. It's very different in terms of this is about shapes and isomerism and drawing them as well. So I'm going to skip that one. That's probably for a different video. Let's carry on with this kind of stuff. And a hydrous aluminium chloride reacts with water solution. Why? Sorry, guys. When a hydrous aluminium chloride reacts with water solution, Y is formed that contains a complex aluminium ion Z and chloridized. Give an equation for this reaction. So when something reacts with water, aluminium chloride reacts with water, sorry. So let's draw our aluminium chloride. Aluminium AlCl3 plus H2O. When this reacts with water, well, what is H2O? H2O is a ligand. H2O is a ligand, so I know I'm going to undergo, what's it called? Ligand substitution. So this, but then what am I going to form? Cl minus signs. Wait, actually, aluminium chloride reacting with water yeah, that's fine, guys. And obviously I need to balance it as 6 here. That's the H2O6 3 plus 3 Cl minus. Given the equation show how the complex ion Z can act as a bond-cell Lowry acid with water. Z contains a complex aluminium ion Z. So Z is Al H2O6 3 plus can act a bond-cell Lowry acid with water plus H2O. And then what's it going to form? It's going to form Al H2O 5 OH H2O 5OH 2 plus H3O plus. Describe two observations when excess sodium carbonate is added to solution Y. Solution Y for solution Y is AlH2O6 3 plus. So if you add carbonate ions to that, what happens? That's what it's asking for. Add carbonate ions to that, you get a white precipitate, and you also get effervescence. White precipitate, effervescence, and then equation for the reaction include formula. Wait, what? Give me an equation for reaction include formula when solution Y, which is this, is added. Okay, so that's pretty simple. 2Al H2O6 3 plus 3CO3 2 minus RO2 bracket Al H2O 3 OH 3 plus 3H2O plus 3CO2. Perfect. And then aqueous potassium hydroxide added to solution Y. So what is this? Well, that is hydroxide ions. So two observations when hydroxide ions is added to AlH2O6 3 plus, or AlH2O6 3 plus hydroxide ions until in excess. So in excess, are you going to get a white precipitate. Okay, it gives me that. So the equation 1 is when it's Al H2O 6 3 plus 3 OH minus arrow Al bracket H2O 3 OH 3 plus 3 H2O. That should be there. That's equation 1. Observation 2, colorless solution. And this is when you want to add in excess. And when you add in excess, this is the equation that happens. So then it's Al H2O 3 OH 3 plus OH minus arrow Al bracket Al H2O 2 OH 4 minus plus H2O. Question 5. I only got 3 more pages. Question 5. Following tests were carried out to identify unknown green salt Y. An aqueous solution of Y gave a cream precipitate of compound A when reacted with silver nitrate solution. Compound A gave a colorless solution reacted with concentrated ammonia solution. Another aqueous solution, this gave green precipitate when reacted with this. Identify the name of formula compounds this. 5 marks. Okay. Once you've done the bare minimum for this topic, which is, well, not for this topic, obviously. Yeah, for this topic, which is memorize all the equations off by heart, like the back of your hand, and you've memorized all the stuff about this. There's nothing to worry about once you memorize all the equations. You just need to, once you're given like a question like this, which looks complicated, you just need to break it down. Like, what's it asking for? When it says aqueous solution of Y gave a cream precipitate of compound A when reacted with silver nitrate solution. So what is A? The aqueous solution of A. of Y gave green precipitate of compound A react to a silver nitrate solution, and it's a green salt. And then A gave a colour solution react to a concentrated ammonia solution. So it's going to be AgBr simply from the fact it gave a colour solution react to a concentrated Na3 solution. Then B, aqueous solution of Y gave green precipitate B when reacted with sodium carbonate. Okay, so then I'm going to go to I'm going to recall my formulas from reacting with sodium carbonate, CO3 minus, and I know I'm going to get a green precipitate B. Well, the only one where I get a green precipitate is with FeH2O6 2 plus, and therefore that tells me B is FeCO3. And then therefore C, so that's FeCO3. C is when green precipitate is filtered, dried, reacted with sulfuric acid. So then when you want to react FeCO3, react sulfuric acid to give a colourless gas D. Well, the colourless gas, okay, so it gives a pale green solution containing with H2SO4. H2SO4. So you're going to get FeSO4. Identity of D, colourless gas, obviously going to be carbon dioxide. So you can literally just use logic for that one. And then Y, well, Y is FeBr2. Simple ionic equation for that silver nitrogen solution. Anion meaning negatively charged ion. So Ag plus Br minus to form AgBr. Simple ionic equation occurs between the green precipitate B, FeCO3, and sulfuric acid. FeCO3 and sulfuric acid well, the ionic equation. So the ionic equation, I only care about this. What's the main thing in here? Well, CO3 2 minus. With the sulfuric acid, so I only care about the H pluses. Well, then that's just your normal equation, and you form CO2 plus H2O. Hexa equal ion reacts to X's hydrochloric acid ligand substitution reaction given equation for this reaction. Hexa equal ion 3 ions. Okay, so that's just FeH2O 6 3 plus. They just try to confuse you with those extra big, like that big number word. And then obviously reacts with HCl, so Cl minus, ligand substitution. You need a 4 here, and then you form FeCl4 minus plus 6 H2O. While the initial and final ion 3 complex in the equation both have different shapes, well, Cl minus, you should know this, is a big ligand. Okay, I'm going to say is a bigger ligand. And what does that mean? It means only four Cl minuses can fit around the metal. Part C, hexagonal react to excess of this. In the ligand substitution reaction, show the structure ion complex formed, showing its charge. Well, if it's a ligand substitution reaction, I've got FeH3 plus, which is that 6 3 plus, reacting with this. Well, ligand substitution, so I'm just going to have Fe, whatever that is. plus H2O. That's all I'm going to have. It's taking way too long. Okay, so it's just going to substitute it. It tells you ligand substitution. So it's just going to be Fe. I'm going to have 4 NH2s. So I'm going to have NH2 here. H2N here. H2N here. But how many will I form? 1, 2. Obviously, I've got this. I've got 1, 2, 3. But in a substitution reaction, so I'm going to have this. And I'm going to have NH2. And I'm going to have N here. I'm going to have N here, NH2 here. And then I need to join them like this. Sorry, that's there. And then I can't forget the big square brackets, and this is 2 plus charge. So what I would do is first write down the equation and then write down the formation and then write down what your formula of what you're doing. Okay, hexa equal 2 ions react with excess of this ligand substitution reaction. Which following suggests the correct change in entropy for reaction of this? Change in entropy is negative, change in entropy close to 0, change in entropy is positive. Change in entropy is positive. It's always going to be that for this. For obviously this case it is obviously is. And yeah, it is. Okay. Use an equation reaction iron 2 ions with manganese ions. So again, this equation you do need to know. 5Fe2 plus MnO4 minus plus 8H plus RO Mn2 plus 5Fe3 plus 4H2O. Four marks, okay. If I see 4, I'm like, okay, that's calm then. Calculate percentage of iron ensemble iron tablets. When I see 6 marks, then I'm like, okay, there's gonna be some tricks here. Okay, shouldn't dissolve this much. So first things first, find the moles of the manganate ion, potassium manganate, which therefore is going to be 0.0200 times by 32.5 divided by 1000 moles of concentration volume. (6.5 times by 10 to the power minus 4). Iron percentage of iron, that's the moles of manganate ions, 1 to 5 molar ratio or 5 to 1 molar ratio. So then I need to times it by 5, and I get 3.25 times by 10 to the power minus 3. So you do have to. It's kind of an unfair question because if you haven't memorized the equation, you wouldn't know the molar ratio, and therefore you wouldn't be able to get the second mark, and therefore you ain't going to get the third mark, and you ain't going to get the fourth mark because those two are going to be wrong. Then that's the molar ratio, that's the moles, and then moles of mass for MR mass is moles times by, but in this case it's in milligrams, so 1.980 grams. No, sorry. I'm going to do the moles times by the MR, 3.25 times by 10 to the power minus 3, because I want the mass, times by the MR, and you get 0.18 ml of iron, which is 55.8. You get 0.181 grams, and then therefore you can just do 181 over milligrams over 198.0 times by 100, and you get 9.14%. Not too difficult, you just need to memorize the equation. Stated color changes at endpoint is titration. Colorless to pale think coordinate bonds form a transition metal reacts with ligand. Explain how its coordinate bond is formed. Electron pair on the ligand is donated from the ligand to the central metal ion. Here's what you observe in dilute aqueous ammonia is added dropwise in aqueous solution containing copper 2 ions. So find out the equation for copper 2 ions. So there, and then to excess. So to excess, I'm going to include both equations. So equation number 1, you get Cu H2O6 101. It says 2 ions, so that tells me the charge is plus 2 plus 2 NH3 arrow Cu H2O 4 OH2 plus 2 NH4 plus, and then equation number 2 is until excess, and then it's Cu, what you just formed, CuH2O, this thing, H2O 4 OH2 plus 4 NH3 forming Cu. Now it's getting a bit more complicated. Cu NH3 4 H2O 2 plus 2 H4 plus 2 OH minus. Whew. OH minus. Okay, that's all it wants, surely. Surely that's all it wants. Oh, it is 4 marks, so now we need to include the observations. Well, the observations, blue solution. The observation in this case, that would be blue solution gives me brick red precipitate, and then the blue precipitate gives me deep blue solution. Deep blue solution. Write an equation with a complex sign reacts with 1,2 dimethyl ethane. Ammonia molecules, but not the water molecules, are replaced. So 1,2 dimethyl ethane. It tells me the ammonia molecules are replaced. So I've got Cu NH34 H2O 2 plus, and you need to know the formula of this as well, plus H2N CH2 CH2 NH2 to form, well then ligand substitution, Cu H2N CH2 CH2 NH2 bracket H2O 2 plus. The only thing that's being, it tells me the water molecules are not replaced, that stays the same, but the ammonia is plus 4 NH3, and then you need to balance it. Well, if I've got 4 NH3 here, I need a 2 here. Yes, I need a 2 there to get that much. Explain, suggest why the enthalpy for reaction approximately 0. Okay, Cu and bonds formed have similar enthalpy slash energy to Cu and bonds broken, and the same number of bonds are broken and made. Explain why the reaction part C occurs despite having an entropy change that is approximately 0. Well, I'm going from 3 particles to 5. So 3 particles form 5 particles. That tells me entropy change is positive, hence Gibbs free energy change is negative, and that's why the reaction occurs. Because this one's really important. Gibbs free energy change positive. Most students might get this. Once you've memorized the equation, you're like, okay, yeah, 3 particles form 5 particles, entropy change positive. But then remember this really important equation that you have to know and understand what it means. Well, then therefore entropy change positive, therefore Gibbs free energy change is still negative. What form of solution was solid sodium carbonate added solution, gallium nitrate, carbonate, ions added to gallium 3 nitrate. I'm going to form it's going to be D. There's no point in me taking too long on this. It's going to be D. Question 9, which compound is colorless when excess dilute aqueous ammonia is added? Excess dilute aqueous ammonia is added. B, silver chloride. What's the final species produced when excess aqueous ammonia is added to aqueous aluminium chloride? B. Question 11. Writing equation includes state symbols for overreaction of iron with oxygen. Iron with oxygen and water vapor to form this. Well, what is this? Fe3OH. No. FeOH3 including state symbols. This is definitely an old spec question, I think. So I'm going to have Fe solid plus water plus oxygen. And then you balance it. Should be a 4 here as well. See how this type of corrosion is not seen in aluminium that have been in close environment for the same time as that. Well, aluminium metal forms an oxide coat, and the coat prevents further reaction. And that is reactions of ions in aqueous solutions question paper. Now, a bunch of equations you have to memorize, yes, but these next couple of days I will be going through them.